So here we are to see the actuators. I again told you that we already studied this concept, but today I'm going to repeat it because this is important one. And from the next lecture, we are trying to take the numericals. So just an overlook on this concept of actuator here. So what is actuator? Actuator are those components of fluid power system which produces mechanical work output. Means whenever we are going to use hydraulic system, we need to convert the energy of oil or energy of hydraulics. So here the actuator it is the device which is used to convert the hydraulic energy of oil into mechanical work output. You can see on your screen. They develop force and displacement which is required to perform any specific task. The task may be of any kind: to move, to press, to lift, or to clamp. So application of this actuator, you can say that application will be to move, to press, or to lift. Then actuators are common for both hydraulic and pneumatic system. You know, just wait a minute. You know, in a actual hydraulic system, we are going to use the oil, and in pneumatic system, we are going to use the air or compressed gas. So, whenever gas is used, then actuator becomes pneumatic actuator, and when we are going to use the hydraulic oil, then actuator becomes hydraulic actuator. Actuator, it is the common component which we are going to use in both hydraulic as well as pneumatic system. The difference, you can say that in pneumatic system we are using the compressor, and in hydraulic system we are going to use the pump. Okay, the hydraulic actuators are made stronger to withstand with high pressure of oil and develop huge amount of force. When we require huge amount of force means more 2 bars. When we require to produce pressure or force more than 2 bars, at that time we are going to use the hydraulic actuator. And for small load or for small pressure which is below 5 bar, at that time we are going to use the pneumatic actuators. Then these are the terms related to the actuators. So first term is speed. While selecting actuator, which qualities should be checked? So these are listed here. Speed of actuator, it should be taken in account while selecting the actuator. Then flow control, flow rate or force developed by the cylinder, it also should take into the account while selecting the actuator. Force of actuator is controlled by controlling the pressure of working fluid using pressure control valve. How we are going to use pressure control valve, flow control valve? We already see it in this chapter. Then direction of motion of actuator is controlled by controlling the direction of flow of fluid by using direction control valve. I already showed you 3 by 4, 3 by 2 direction control valve, 4 by 2 direction control valve. How we are going to use this control valve to get the desired motion of actuator? We already see it in previous lectures. Okay. So here we are going to see the types of actuator. So there are two types of actuator mainly. First one is linear actuator and second one is rotary actuator. Here you can see this video here.
The purpose of a fluid system is to transmit.
What I told you theoretically, that actuator is used to convert the hydraulic hydraulic pressure of oil into mechanical output. So this is just shown here in animation format. Just listen it.
The purpose of a fluid system is to transmit power from one location to another. Fluid power is converted to mechanical power by means of an actuator. Cylinder actuators deliver a linear push-pull motion.
Here what is happening, you are just using the pressure of oil, and from this pressure of oil we are getting the piston moves inward and outward. So what is happening here, we are converting the pressure of oil into the mechanical output here.
Via a rod and piston within a cylindrical tube. A single acting cylinder is a cylinder in which the working fluid acts.
It is single acting, single ended cylinder, means there is only one connecting rod is connected to the piston, and single acting means there is only a single port through which high pressure oil comes and goes out from the actuator. That's why it is called as single acting. And why single ended? Because only one connecting rod is connected here.
On only one side of the piston. The other side of the cylinder utilizes a mechanical load, springs, compressed air, other cylinders, or the momentum of a flywheel to push the piston back in the other direction. This particular cylinder utilizes a spring on the non-fluid side. A single acting cylinder produces.
Here we are using the spring to bring the piston back to its original space when the pressure of liquid from this side is removed. So what is happening here? Only pressurized oil remains only on one side of this piston. That's why it is called as single acting. And when both side of the piston remains oil, then we will call is at double acting cylinder.
Produces linear motion in one direction. When a control valve directs fluid through the inlet port into the blind end, pressure builds up and generates a force on the piston. When the pressure buildup is large enough, the piston begins to move, extending the rod. This is called the forward stroke. When a control valve directs fluid out of the port, the fluid pressure is removed. The force of the spring pushes against the piston in the other direction, and the rod returns to the cylinder. The purpose of pumps and hydraulic double-acting cylinder is a cylinder in directions.
So this is the working for single
A
acting
double-acting
cylinder.
cylinder is a cylinder in which fluid acts on both sides.
Now this is double acting cylinder. There is another second port is present to the other side of this piston, so that oil is present on both sides of the piston. That's why we are calling it as double acting single ended cylinder, because there is only one connecting rod is connected and oil is present on both sides of the piston. That's why it is called as double acting single ended cylinder.
Sides of the piston. This type of cylinder can produce linear motion in two directions. A double-acting cylinder has two fluid ports, one on the blind end and one on the rod end. A directional control valve sends fluid through the blind end port while venting fluid out the rod end port back to the tank. Pressure builds up and generates a force on the piston, causing the extension stroke. When the directional control valve is shifted, it sends fluid into the rod end port, out of the blind end port, and back to the tank. Pressure builds up and generates a force on the other side of the piston, causing the retraction stroke.
So these are the working stroke, extension and retraction. We are going to achieve it by both the stroke of extraction and retraction by
a fluid system
using
is
the pressure
into
of
the
oil.
rod end, causing action. We
are achieving both this stroke by the pressure of oil, and in single acting cylinder we are achieving the retraction stroke by spring action.
To determine the speed of a piston during extension and retraction, we must
This is the internal structure of our actuator. Let's see it.
first determine the significant working areas. The full piston area is the side of the piston without the rod. This is the area that feels pressure as the piston extends. The next significant working area is called the net area. This area is the size of the full piston area minus the area of the rod. The net area feels pressure when the cylinder or the incoming fluid takes up space. The cylinder will always retract. Fast cylinders work simple. Flow rate is the same and the piston areas are the same. The speed for extension, although their motion is linear,
So here we are to see the types of actuator. So there are two types of actuator. First one is linear and another one is rotary. Here on your screen you can see the types of linear actuators again. So linear actuators again having three types. First one is rotary cylinder, then second one is non-rotary cylinder, and third one is the special type cylinder. The rotating cylinder, don't go on this on the name of this rotating. It is linear actuator, means its cylinder is only rotating but it produces the linear motion. Linear motion produced by actuator, then it is called as linear actuator, and if it is producing rotary motion, then we name is as rotary actuator. Here rotating cylinder means here cylinder is only rotating